Okay, so this video we're going to be looking at how to solve exponential and logarithmic equations. So let's take a look at a few examples of each of these. So for an example of an exponential equation, we could have something that says 2 to the 3x minus 8 equals 16. So the first thing you want to do is you want to check to see if you can rewrite both sides so that they have the exact same base. So if we're looking at the bases, right now we have a 2 and a 16. We're able to rewrite 16 as 2 to the 4th power. If we do that, we're going to end up with 2 to the 3x minus 8 equals 2 to the 4th. So we have 2 to a power equals 2 to a power. And because we have an equal sign here, and because we've established exact bases, or the same bases on both sides, what we're able to do is we're able to rewrite this equation as the exponent on the left side equaling the exponent on the right side. And then it becomes pretty simple to solve at this point. We would add 8 on both sides. 3x equals 12. So x equals 4. So that would be the solution to the problem. Now you would use this method if you notice that you can establish the same base on both sides. Then you can go right ahead and simplify and then set the exponents equal to one another. This can't always occur though. For example, if we have 4 to the 2x plus 3 equals 5 to the x minus 2. If we look at this problem, we have a base 4 and a base 5. We're not able to establish the same base on both sides. I cannot write 5 easily as 4 to a power. So what we need to do is we need to incorporate logarithms into the problem. So what you would do is you would introduce ln on both sides. So you would literally just write down ln on the front of both sides. Once we do that, once we introduce the logarithms into the problem, what we can do is we can use the the power property, where we would take the exponent and I like to use the word flick. I used to flick it in the front. So 2x plus 3 as a quantity times ln 4 equals, we're going to put x minus 2 in front of ln 5. Now that we have this, what we're able to do is we're able to we could either divide both sides by ln 4 to cancel it here, or we could divide both sides by ln 5, or we could just write down the decimal approximation of ln 4 and ln 5. So ln 4, if you were to put that on your calculator, is approximately, let's round it, 1.386 approximately. And then ln 5 is approximately 1.61. So at this point, you see it's pretty easy to solve for x, because we've converted ln 4 and ln 5 to decimals. So if I distribute the 1.386 into both of those terms, and the same with the 1.61, so 1.386 times 2x would give you 2.772x plus, and then 3 times 1.386 would give you 4.158. 1.61 times x is 1.61x minus 1.61 times 2, 3.22. Now let's get the x's on one side, so I'm going to subtract 1.61x on both sides. So 2.772 minus 1.61 is going to give me 1.162x. Now I want to subtract 4.158 from both sides. So negative 3.22 minus 4.158. So we're going to have 1.162x equals negative 7.378. Now let's divide both sides by 1.162. So x is going to be approximately negative 6.35. Well, a lot of this is calculator work. So what we need to do at this point, and this is really, really important, so always check your solutions. Really, really, really important. So I need to check to see if I substitute negative 6.335 in for x, will it cause any problems? So I go all the way back to the problem here. And if I plug in that negative 6.35 in for x, I'm not going to run into any issues, because at worst it's going to create a negative exponent, and 4 to a negative exponent and 5 to a negative exponent is perfectly fine. What you really need to make sure is check your solutions when you're solving a logarithmic equation. So I got a little bit ahead of myself here. So check your solutions for logarithmic equations. Now, what a logarithmic equation is when you start the problem off with a logarithm, and the x value would be part of the n value, and I'll show you what I mean by that in a minute. In that case, if it causes n to be negative, then you actually cannot take your solution. You would have to throw that solution out. So let's take a look at an example of a logarithmic equation. Let's say we had something that said log base 4 of x plus 3 equals 2. Alright, this is an example of a logarithmic equation where you're going to have to try to solve. It's a logarithmic equation because it's not written as a base to a power equals a value. It's written as a log or an ln with a particular base of n equals an exponent. So for this problem here, what you want to do is you want to simplify as much as possible and then write it in exponential form. And you would do that if there's a logarithm only on one side, which this is an example of. So what you would do is simplify the left-hand side as much as possible, and it already is. You can't simplify that any more than it is. And then you want to write it in exponential form. So we would have 4 squared equals x plus 3, which is 16 equals x plus 3. And then when you subtract 3, you get x being 13. Now again, we need to check the solution. So this is where I was I really meant to say that important rule is this part right now, because this is a logarithmic equation, and if this x value would cause this n value to be negative, then you would not accept this solution. But if I were to plug 13 in here, I would be absolutely fine. Or it, not me personally, the problem would be fine, because it would then be log base 4 of 13 plus 3, which is 16, equals 2. This is okay, because that's positive. As long as that is positive, you're fine. So this solution checks out. If you were to have gotten a solution, for example, x equals negative 13, if you were to plug in negative 13 for x, it would be negative 13 plus 3, which is negative 10. That would cause a problem, because log base 4 of negative 10 is, you can't do that, because that would represent 4 to what power equals negative 10. Well, no power would give you that. So you would have to throw out that particular solution. Let's do another example. Let's say we have log x, so we're dealing with base 10 here, plus log x minus 3 equals 1. Alright, so first step, you want to simplify as much as possible. On this left-hand side here, we have a logarithm plus a logarithm. They are both the same base. They're both base 10. So what we can do is we can condense them, and we're going to condense it by multiplying this n value by this n value. So it's log of x times x minus 3, which is x squared minus 3x, equals 1. So again, this plus sign indicates multiplication. So we're multiplying x by x minus 3. And when you multiply x by x minus 3, it becomes x squared minus 3x. So we're condensing and simplifying the left-hand side. Now that we've done that, this is our n value. We can take the base, raise it to that exponent, and set it equal to the n value. So we're writing it in exponential form. So 10 to the 1 equals x squared minus 3x. So this is a quadratic, and we can tell that by the x squared. So whenever you're trying to solve a quadratic, you want to get everything on one side. So we would have x squared minus 3x minus 10 equals 0. There's different methods to solve a quadratic. So we could complete the square, we could factor if it's factorable, and we can use the quadratic formula. This is able to be factored. It's x minus 5 x plus 2. If it's factorable, factor it. That's the quickest method. So then this would mean that my solutions are 5 and negative 2. So negative 2 and 5 are my solutions. We have to check both of these. So we have to go back into the original problem and check to see if negative 2 and if positive 5 would create n being negative. So this was our original problem. Let me go up a little bit. So negative 2 is a problem, because if I plug in negative 2, I would get log of negative 2 plus the log of negative 5 equals 1. You cannot have a logarithm of a negative value. So negative 2 is not a solution. You have to throw that solution out. What about 5? Well, that would give me log of 5 plus log of 5 minus 3. This is okay because I've got a log of a positive plus a log of a positive. So x equals 5 is my only solution for this problem. So again, this illustrates the fact that you really have to make sure that you check your solutions. Let's do one more. Let's do an example where there's a logarithm on both sides of the equation. Okay, so first step, what we want to do is we want to simplify both sides, or one side if only one side is simplifiable. This side is already simplified, ln of 1 over x. That can't be simplified anymore. The left side here, what we can do is we can condense that side. And this negative sign indicates division. And what am I going to be dividing? This n value by that n value. So I'm going to write it as a single logarithm of x plus 2 over 4x plus 3. And I'm going to set that equal to ln of 1 over x. So we're condensing that left-hand side. Now we have this. So this is sort of you sort of see symmetry here. ln of something equals ln of something else. That would indicate that this here has to be equal to this. And this is sort of a one-to-one situation where you've got that sort of symmetry. So what we can do is we can conclude that because it's ln of something equals ln of something else, that this x plus 2 over 4x plus 3 has to be equal to the 1 over x, because it's one-to-one. So now we just we solve. So we can look at the sort of the extreme mean ratio here. We can a little less eloquent way of putting it would be cross multiplying. So x plus 2 times x would be x squared plus 2x, and then the 1 times 4x plus 3 is 4x plus 3. Now we want to get everything on one side. So x squared, if I move this 4x over, I'm subtracting 4x from 2x, so I'm going to have negative 2x. And I'm moving the 3 over, so I'm going to have minus 3. Now if this is factorable, factor it. And it is factorable. You have an x and an x, negative 3 plus 1. So your solutions are negative 1 and positive 3. So now we need to check to make sure if negative 1 and 3 cause any issues. So we're checking negative 1 and we're checking 3. So let's first check negative 1. If I put a negative 1 in here, negative 1 plus 2 is positive 1. That's a positive. We're fine. If I put it in here, 4 times negative 1 is negative 4. Negative 4 plus 3 is negative 1. That causes a negative. That automatically disqualifies negative 1. It would disqualify it here also, because 1 divided by negative 1 is negative 1, and that is a problem. So it only needs to not work on one of these for it to be completely thrown out. Now let's try 3. 3 plus 2 is 5, that's fine. 4 times 3 plus 3 is 15, that's fine. And 1 divided by 3 is positive, that's fine. So my answer is just 3. And that's it.